Today we are going to find the reduction formula of higher power of trigonometric function. Here the function is sine, so integration of sine to the power nx dx. N is the positive integer. This is the second reduction formula. We have evaluated first reduction formula in previous question by applying the integration by part formula. Similarly, here to applying the by part formula, first of all we have to extract function of sine which is easily integrable. Sine x, we have the integration of sine x, so this function sine to the power n x is to be break down into two functions, as first function is sine n minus 1 x and second function is sine x. We have the integration by part formula. For this, the first function should be differentiable function and second function should be integrable function, so we separate sine x as the second function b. By applying this formula to this question, first function is u is sine n minus 1 x, integration of second function sine x dx minus derivative of this first function n minus 1 x sine power n minus 1 x and integration of second function sine x. We get we have integration of sine x is minus cos x. This function remains the same, minus the sign of integration. The derivative of sine n minus 1 x dx is n minus 1 sine n minus 2 x multiplied by cos x, since by applying the chain rule of the derivative, and integration of sine x is minus cos x. This become, on simple calculation, the second function become n minus 1 time multiplication of sine n minus 2x time sine cos into cos multiplied with this cos square x. This negative sign and this negative sign become positive sign. Again, the first function remains same, plus n minus 1, and we need to convert this cos square x into 1 minus sine square x. Since our question is sine to the power nx, so we have to convert this function into the suitable function based on the question. So this second function become, we have to multiply 1 minus sine square x by this sine to the power n minus 2x. We get sine n minus 2x dx minus n minus 1 also multiplied for the both factors, and this sine n minus 2x and sine square x, the base is same, so power becomes sine n x dx. For reduction formula, we have to compare the power of sine x. For integration, we denote power sine to power nx as in, so these two integrations sine nx and sine n minus 1 dx should be represented by in and n minus 2x dx to in minus 2. These two function in minus 2 and in, we have to arrange this function as this in and this in are same degree, so on simplification we get the value of in is equal to minus time cos x into sine to the power n minus x by n. This in goes to the left hand side, and simple calculation we get this the n value, and this is the required reduction formula of sine to the power nx dx. Now we can evaluate any power of sine by applying this reduction formula. Here we take the value of n is equal to 5, so the value of I5 is equal to sine to the power 5x dx becomes this. From this equation we get I5 is equal to minus time cos x sine to the power 5 minus 1 by 5 sine to the power 4x dx plus n minus 1 4 n5 n minus 2 become I3. Again, the value of I3, we need to put n is equal to 3 in equation 1. We get minus cos x sine n minus 1 x by n 2 and 3 plus n minus 1 by n become 2 by 3 I1. Similarly, for the I1, put I1 is the identity. If we apply the reduction formula, it becomes I minus 1. So we need to stop the applying the reduction formula, since reduction formula is applicable to positive number. So the value of I1 is computed as I1 is sine to the power 1x dx, that is sine x, and the integration of sine x is minus cos x. We need to put the value of I1 here, and we can obtain the value of I5 as sine to the power 5x dx is equal to minus cos x sine to the power 4x by 5 minus 4 by 15 cos x sine square x plus 8 by 15 in 8 by 15, and the value of I1 is minus cos x. This becomes minus 8 cos x by 15. This is the value of I5. Similarly, we can obtain the value of I5, I6, I4, any number from this reduction formula.